back. This is Mr. Hassan's Maths channel, and I am now going to answer question number 8 from the June 2021 International A-Level Cambridge Pure Mathematics P1 paper. This is paper 1, variant 3 from the 9709 syllabus. And this question here is about functions. We have two functions, f and g, which are defined as follows. You have f of x is x squared minus 1. This is just another notation of writing the same thing. So f of x is x squared minus 1, and g of x is 1 over 2x plus 1. They mean basically the same thing. All right, so this means f is such that x is mapped to x squared minus 1. That's the input, that's the output. So solve the equation f of gx equals 3. Now, there's two ways we could tackle this question, and I think the way I'm going to show you first, I'll only show you this way, is it makes life a whole lot simpler, especially when you have this situation here. Now, this is something that's very important in these type of questions. In IGCSE, it didn't really matter what was written here so much because we didn't really talk about domain and range so much. But come to AS maths and A-level maths, these things that are written next to the functions are not just there for decoration. And many people, they mess up functions questions because they don't take care of what the domain that these functions are defined for. So for example, this function only exists for x is less than 0. So if you were to draw this function, which you don't need to do for this question, but just to illustrate to you what I mean, if you were to draw this function, okay, then basically y equals x squared minus 1. If you were to ignore the domain, then you would draw this function looking like this. So it can be quadratic, and it will look something like this. I haven't drawn it so well. It looks something like this, okay? But because you have the domain x is less than 0, that means the x values can never be positive, always have to be negative. So it has to start from 0 with an open circle and continues on forever this way. It doesn't exist on this side, only that side. And similarly for this, if you were to draw this, it will be like a reciprocal type of function, okay? And you would have something like this. You would have an asymptote at x equals minus a half, which is where the function actually begins, okay? And it would look something like this. It would go, if you were to draw it on this side, if we ignore the domain, then when x equals 0, y equals 1, so it would go like that, and on this side it will be over here. So it will be something like this and like this. Now, because the domain is restricted to x is less than negative a half, okay, that means we need to get rid of all of this side. So it only exists on this side. That part doesn't exist. All right, so that's how you draw those individual functions if you had to draw them. We don't have to draw them now. I'm just illustrating to you how the domain matters in such questions, and it will definitely matter in our answer for our question. So the first thing it says is solve the equation f of gx equals 3. Now we could find the composite function, replace the x with 1 over 2x plus 1, and then solve that, okay? But I think what will make it easier, especially with the restricted domains here, is to do it in a slightly different way. Kind of the same thing, but instead of writing here 1 over 2x plus 1, I'm going to write here g of x. So I'm going to find f of g of x, and I'm going to equate that to 3. So I'm going to put, instead of x in function f, instead of this x, I'm going to write g of x. Not what g of x is, but actually g of x itself. So I'm going to write this as, g of x, instead of this x, so that has to be squared, minus 1, and I have to equate that to 3. So now I'm going to find what g of x is from this. So I add 1 to both sides, so I have g of x all squared equals 3 plus 1, which is 4, and then I take the square root of both sides, so I've got g of x is plus or minus 2. All right, now, what we should understand here for this, f of g of x, is the input of f of x is g of x. The input of f of x is g of x. And the input of f of x can only have negative numbers because it's defined only for x values which are negative. So if I'm going to put g of x into this function, whatever goes into this function cannot be positive. It must be negative. So therefore, okay, as f of x is defined for the input x is less than 0, therefore g of x has to equal negative 2. It can't be positive 2. I can't put positive 2 inside the function f because it's not defined for any positive values, only for negative values. So what I'm going to do now is I'm going to equate g of x to negative 2. I won't equate it to 2. I'll equate it only to negative 2. So I'm going to take g of x and equate it to negative 2. So I'll have 1 over 2x plus 1 equals negative 2. And then I'm going to solve this equation. So I can solve it easily by cross multiplying here. So I'll put negative a half equals 2x plus 1. It's like I've multiplied both sides by 2x plus 1 and then divided both sides by 2 in one step. And then I can subtract 1 from both sides. So I have minus 1 half minus 1 equals 2x. That's minus 3 over 2 equals minus 3 over 2 equals 2x. Therefore, we can say x equals negative 3 over 4. That is the only solution. Now, if we didn't take care of the fact that f of x can only take negative inputs, we would have also put we would have also used to solve the equation 1 over 2x plus 1 equals 2. And then we would have got another value of x, which would not be a valid answer. That value has to be rejected. Okay, the other way of doing this question would be to actually replace, as you'll see that I'm going to do in the part B, replace the x with 1 over 2x plus 1, and then solve for x. Equate it to 3 and then solve for x. But then it doesn't become very clear. This makes it much clearer about what we can put into function f. It makes it much clearer for us. So if we do this way first, okay, I think this makes it much clearer. Okay, so replace the x in f of x with the actual expression g of x, not what g of x is equal to, but just g of x. And then you see what does that come out to. If it's something which is, valid for the range, we use it. If it's not valid for the range, we don't use it. Just imagine that's the thing that has to go in here. If that value that's going in here is something that isn't within the domain of function f, you can't put it in there. You can't put it in there. Okay, so that's very important for us to understand. Okay, so there's the answer to part A. Now for part B, it says find an expression for the inverse of f of g of x. Okay, so for this, what I'm going to do first, I'm going to first find what f of g of x is, and then I'm going to find the inverse. So f of g of x is basically almost exactly what I did last time, but I'm going to now replace the x here with 1 over 2x plus 1. So I'll have 1 over 2x plus 1 squared minus 1, which if you just simplify a little bit, we don't have to expand the brackets, but I know that 1 squared is 1. So 1 over 2x plus 1 squared minus 1. I can leave it like that as my answer. That's not my final answer, of course. That's just f of g of x. Now we have to find the inverse. So we can now find f of g minus 1 of x, as they've shown it. So the first step would be to replace the f of g of x with y. So all right, y equals 1 over 2x plus 1 squared minus 1. And then I'm going to switch the x and y around. So wherever I see y, I'll call it x. And wherever I see x, I'll call it y. Okay, so I end up with this expression here, with this equation here. Now I'm going to make y the subject. Now when I make y the subject, I'll end up with the form of the inverse. So first, I think I'll add 1 to both sides. So I have x plus 1 equals 1 over 2y plus 1 squared. Now I can cross multiply or multiply both sides by 2y plus 1 squared and divide both sides by x plus 1, in which case I'll get 2y plus 1 all squared equals 1 over x plus 1. Now comes the part where we have to think a little bit, which I'm going to explain. So first of all, I'm going to do this as if it's not a function, because I know that when I find the square root of this, I'm going to have either plus or minus the square root of 1 over x plus 1. Okay, but we know that our original function was limited, as we know from here, it was only the negative side. So I think that we're going to take the negative square root only. I think we're only going to use the negative square root. But I want to verify that, okay? And this is, I'm going to show you how to verify it. So first, let's make y the subject fully. So you have 2y equals, I'm going to subtract 1 from both sides. So minus 1 plus or minus the square root of 1 over x plus 1. And then divide both sides by 2. So you have y equals minus a half plus or minus. And I can write this as actually 1 over the square root of, or you can say 2 times the square root of x plus 1. Okay, that's now the form of the inverse, but I have to decide what to choose. Am I going to do positive or negative? Okay, so I think it's going to be negative, but let's just verify it. I'll show you how to verify it. Okay, to verify, what we're going to do is we're going to choose a random value of x and put it into the original function here. So I'm going to take f of g of x, and let me just choose, for example, a value of x that's valid is going to be negative value. Let's choose something safe like x equals negative 3. If I put negative 3 into here, the original function f of g of x is going to be given, well, f of g of negative 3 is going to give us, we're going to have 1 over 2 times negative 3 plus 1 squared minus 1. So that's going to be 1 over, that's minus 6 plus minus 5 squared. So it's going to be 1 over 25. It's going to be positive 25 because you square a negative number, minus 1, which gives me minus 24 over 25. So I know that when I put minus 3 inside the original function, I get negative 24 over 25. So if I have the correct inverse, when I put inside the inverse function, negative 24 over 25, the function should be undone, and what should come out is the original input. Okay, so if I put minus 3 into the original function, and minus 24 over 25 comes out, if I have the correct inverse function, then putting minus 24 over 25 inside the inverse will basically undo the function and give you back the input that you originally had. So I'm going to decide now which of these two forms I'm going to use. So let's say we choose the positive side first, although I'm pretty sure it's going to be negative. So I'm put x equals minus 24 over 25 inside the function here. So y equals minus a half plus or minus 1 over 2 times the square root of, and I'm going to have minus 24 over 25 plus 1. So this gives me minus a half plus or minus 1 over 2 times. Now this is going to be 1/5, the square root of 1/5. 1 over 25, the square root of 1 over 25 is 1/5. So you have 1 over 2/5, which is 5 over 2, so minus a half. I'm choosing the positive one now, so I'll just put plus and plus here. So minus a half plus 1 over 2 over 5 is 5 over 2. That gives me a 4 over 2, which is 2, which is not the correct number. That's not what we put into the function. All right, so let's now take x equals minus 24 over 25 and put it inside the same function. So in this case here, we're going to have, you'll have y equals minus a half. You're going to have minus, that's going to be minus, okay, 5 over 2. All right, because remember this is going to be plus, this time it's going to become minus. Everything else will be the same except this is now going to be minus. So you have minus 5 over 6, minus 6 over 2, which is equal to negative 3, which is exactly what our original input was. Okay, so we definitely have the correct inverse function. So we can say f of g inverse of x is equal to minus a half minus 1 over 2 times the square root of x plus 1. This is the inverse function. Okay, we kind of deduced it by the fact that we had a quadratic which we limited to the negative side. Okay, it was like this. Okay, so therefore it's most likely we're going to take the negative square root, and that's exactly what we did there. So that is the inverse function for this question number 8, part B. All right, so I hope that was clear. The question actually says find an expression for, but we have to decide whether it's positive or negative. So you should understand how this little trick here works to verify whether we have the correct form of the the inverse when you have this square root kind of situation. All right, so that concludes this question. I hope this was clear. Thank you for watching. Other questions from this particular paper can be found in the playlist, which will appear in this region over here. You can subscribe to my channel by clicking on this link. You can watch other questions from functions of P1 of Cambridge from this, this link that will appear in this area over here. And there's a video which will be linked in this section, which will tell you how to use my channel to find things you might be interested in finding from edXL or IGCSE material. Thank you for watching and see you soon.